and steady, not like a chicken trying to shake the shit off its back legs. And the wooden board, just in case. That's what we want. Now to do the same for the other end. Okay, this is that little adjuster rod that we just made in place. So next we'll make up a couple of probably brass little handles, hand wheels for either end of it. Now I did intend to make this a 2-start thread, but until my tool and cutter grinder is up and running, I can't accurately grind the lead clearance angles for such a small single point tool to do a 2-start thread in the block here. But we'll cover that, we'll cover these multi-start threads in another video. So anyway, so we'll find some material and we'll make the hand wheels. Let's put a larger nose radius on this tool so we can pick up on this finish a bit. Let's just brass this. We'll try that. That's looking a lot better. So what we're making is a brass knob for each end of our jigaboo here. So we'll get it in the mill, and I think rather than knurl it, we'll just mill some flutes down it. So we'll get this one set up in the indexing head and a ball nose cutter set up and cut our flutes. So I'll just use our edge finder here. I normally run them around about 1000 RPM. And just come back to double check it. It. So I'll just come across half the distance now. I'll just zero the dial down here. So our shaft is 21.08, so half of that's 10.54, half of our edge finder is 2.54, so we come across 13.08. We'll be where we need to be. 10, 11, 12, 13.08. Okay, that brings us on centre. We'll get a cutter set up now and we'll start cutting these flutes. So we're going to cut 12 Tom Lipton style flutes in our knob here. So with this indexing head here, there's 4 methods we can employ to get our 12 divisions. The first and simplest way is direct indexing, just through this detent lever here, and there's a series of holes behind this plate. The other way is plain indexing, where we use the indexing plate here. Now, most of your indexing heads have a smaller plate, but this style is a bit different. This is the Cincinnati style of indexing head, and the other system is a Brown and Sharp system. With the plain indexing, we can either do 3 rotations of the crank handle and 9 holes on a 27 hole plate, or we can do 3 rotations of the crank handle and 13 holes on a 39 hole plate. And the fourth way to do it is we use the wide range feature. So we use our 100 hole plate, and we also use the internal plate here, so we use both handles. So they're all much of a muchness. So we're just going to use the plain indexing. So I've set this up for to use the 39 hole plate. So it's 3 rotations of the handle, 13 holes on a 39 plate. Should do a video one day on how you actually work this stuff out, because it's all your divisions are done for you in the machinery's handbook and the black book and books like that. But you may get caught out one day and you're not going to have a book with you. You still helps. It's handy to know how to actually work it out, how to go through the fractions, the process of doing it. So we'll do a video on that one day. So anyway, let's get our flutes cut. So we're not going to any particular depth or anything, we're just going until it looks right. So Okay, so we're back to the beginning. We'll just have a bit of an eyeball on the depth, just the feel. It actually looks quite good, feels good. What I think I'll do is I'll just take a very light cleaning cut just to get some of those tool marks out. Just another couple of thou off it just to clean it up, and I think we'll let it go at that. Well, I think we're onto a winner there. It's come out rather well, that. Okay, so our next step will be to put it in the lathe, and I think we'll sort out a couple of form tools so we can just plunge in and cut our knobs. That should be okay. Okay, here's a bit of a rough sketch of what we're actually making, our knobs. So we're going to machine the two of them in one setting back to back, and then before we part them off we'll pop them back in the mill, as the mill is still on centre from when we cut the these grooves, and we'll pop through these two tapped holes, and they'll be for a locking grub screw to hold the knobs in place. So we'll get it set up in the lathe and we'll cut these radius features. So we're just going to use this radius tool, and that will cut our radius. And I just always use my vernier height gauge just to set the tool on centre. It's not a tool I very rarely use those things. I'd like to get a digital one day, because this is an old Brown and Sharp one, and as most of you know, with Brown and Sharp gear you've got to pretty well use a magnifying glass to see the numbers. Okay, that's where we want to be. We'll set it sort of probably. No, we'll go like that. We'll plunge straight in. Give it a bit of sideways wiggle as well. So we better have a look at the distance we're going to machine back. So we have our grub screw here, it's a 3/16 grub screw. So we can go back another couple of mil yet on our cut. Just want to leave enough meat between the end of the knob and the grub screw, so we'll take a bit more off. It's just all eyeballing this, so there's no dimensions. So now would be the perfect time. We have to drill and ream a 6mm hole through there. So now's the perfect opportunity. test fit with our shaft, I think. Yeah, no, we're going to have to put that reamer through. Okay. I was hoping it would just drill a fraction oversized, but it's drilled smack on size. Slow our lathe down a bit. Put a bit of WD on this as well. Okay, so we'll head over to the mill and we'll get set up and we'll drill and tap our 2 grub screw holes and then back into the lathe to do a couple of chamfers and part them off. So we're going to tap our knob number 10 UNC, but I don't have a number 10 UNC grub screw. I do however have a 3/16 Whitworth one, so they're both 24 TPI. The Whitworth is a 3.7mm tapping drill. The UNC number 10 is a 3.8. So we'll go with the 3.8 tapping drill and we'll tap it number 10 UNC, and the 3/16 Whitworth grub screw will fit. So that's an oldie, that's one I've had since I was an apprentice. Tapping all the technical charts, half the pages stuck together. Wonder what we used to get up to. So I have these 2 drill sets. Now this is a metric. I've got the 5mm elsewhere. It's missing. It's not missing. It's here. I've modified it to. I had to drill for a dowel, so I just stone the edges down so I get interference fit with a dowel. If you don't have the correct size reamers, you can do that. So these 2 drill sets I keep purely for tapping size drills and reamers and special application holes only. That way it keeps them good. This set here is a metric set. This goes up in 0.1mm increments from 1mm to 6mm. So 1.9, 1.8, 1.7, you know. So, and this goes up in 0.5mm increments. So it's just 2 sets that I use for nothing else except for a tapping drill when I haven't got an imperial that'll work, or for drills for reamers. So all my other holes, I've got a whole heap of old imperial drills, and normally I'll just use those. So anyway, we'll put a mark in with a. Well, actually, might. Yeah. Well, just umming and ahhing. I was going to use a spot drill to put a mark in, but I might actually use a centre drill on this application, as our hole's going to be pretty small. So, and then we'll pop our tap through. Okay, our spot drill, I'm just going to put it in the chuck upside down. I'm not going to tighten it up. I'm just going to use it as a visual reference to centre our hole. So what I'm going to do is just pick up off the edge of the drill shank against the edge, the top edge here of one of the flutes. That's pretty good there. So I'll come to a complete 1mm graduation mark on the table. I'll move the table. It's 1mm. We'll go another mil. Okay, so we're 2mm away. Okay, we'll drill it there. So what we'll do, we'll repeat the process when we come to this side here. We'll pick up the same, we'll come 2mm off the corner of the flute there. And we'll lose our our centre drill disappeared in the T-slot. Okay, here we go. Had to go fishing for it. Okay, we're away. And we're looking in a good position there. And our tap. I'm just going to slip the milling machine in neutral and just very gingerly go down by hand. I did used to have a miniature tap wrench that went missing. It was exact replica of the style. This is a Morum right, but it was only a little wee one that I made up when I was an apprentice. It was all hardened on the ends where it grabs the tap and everything. I'll have to make another one day. So the old shifter will have to do. That's the starter tap. So we'll go straight through with the bottom tap. feels like it's through. Which it is. Tap follower, that's a tool that I could do with. I might have to make one day if I ever get the time. Survived this long without one, so okay. We just pop our spotting drill back in and we'll just chamfer the top of that thread. Okay. I'll try and keep it in the picture. Bad light, but yeah, there's a good tapped hole in there and a good chamfer. So we'll repeat the process for the other side. Right, we're back in the lathe, ready to part this in half. So I'm actually just going to slip a new insert in the parting tool holder. I use these S-car inserts. It's an S-car blade. So these are, if the camera will focus. No, camera's not going to focus. Okay, let's go. Oh, by the way, that sound, that's not chatter. That's the flutes on the parting tool making that noise. Okay. Oh, it's a bit warm, that. Now, very rarely will you ever see me part off dry, but because this is brass, it's okay. Okie dokie. Next operation is to get these set up on a mandrel, and I want to do a bit of a decorative feature on the end, and then we can chamfer them on the mandrel as well. There's our two knobs. We'll get them set up on a mandrel. So we've turned up a little 6mm arbor and just filed a little flat on the top, so the grub screw has something to lock down onto. So we'll just nip these down. We'll just take care of these sharp edges. Okay, so we'll move on to this side here. So I think we'll probably give it we'll give it a bit of a chamfer on the edge. We might put a bit of a, we'll put a bit of a dish radius on the face. Just making sure our angles sort of match where it blends in from the radius. We'll just take a fraction deeper on that one. Yeah, that's the ticket. Fraction more. And a fraction more. That's the same. Okay, we'll get set up for a tool to do our radius feature on the end there. Right, we have our radius tool set up, so we'll just plunge into the face and see how it reacts. That's quite good. I think we'll do the other one the same. compare the two. It looks pretty good. Okay, we're getting there, so all I have to do to these parts now is drill and tap for a locking screw in there. So I'll drill and tap the same thread as we done on those knobs there. So that was number 10 UNC. So I'll drill and tap that side, and I'll drill right through with a smaller hole. So an Allen key can pass through a smaller hole on this side and enter into the grub screw to tighten up. So the grub screw will pull up and it will pull down on the V's, therefore locking the two end pieces in place. So the next thing we've got to look at is this part here. We've got to put a hole in here. Yeah. Goes on this side. So we've got to come to some arrangement here so we can do this rod that sticks out here. So whether we do, I was going to do a square one, but I'm a bit undecided at this stage, so I'll see what materials I've got and see what we come up with. Oh, well, we're coming close to the closure of this piece, so we've got our arms to come out the front, as we spoke about just now, and the little finger indexer that sort of goes on the end of the arm. So every little part made is one step closer to putting our tool and cutter grinder back into action so we can start sharpening our own milling cutters. So anyway, thanks for watching, and there'll be a shed update video before too long too, so I've been working pretty hard on that, so expect that one out in the next couple of weeks, I hope. So we'll see how we go. So anyway, take care, take it easy, and we'll hopefully see you in the next video.